This is our part 5 of our lesson on operations with logarithmic functions. So question number 5 says, for the functions e of x, which is log of 5x to the 8, f of x, which is log of 20x to the 14, and g of x, which is 2 log 5x, determine a simplified expression for e plus f minus g of x. Now I did notice that none of these logs appear to have a base. So we did talk in our previous unit that when you have a log with no visible base, it is log base 10. Now I don't really need that for this question, but just know that it is log base 10. All right, so we are doing e plus f minus g of x. So I am doing e of x plus f of x minus g of x. All right, we are going to substitute in e, f, and g. So e is log of 5x to the power of 8. F is log of 20x to the 14. And then g is 2 log of 5x. Okay, so when I'm doing a question and I'm trying to decide whether to collect like terms or whether to use log rules, I'm going to look to see, are these like terms? If they're like terms, I would try to see if I can collect like terms. And if they're not like terms, then I'm probably going to use some log rules. So I do see that they are the same base. They're all log base 10, right? Are their arguments the same? No. So these are not like terms. So either I have to find a way to make them like terms, or I need to try using log rules. So I often do not try to make things like terms unless I know that it's going to help. I would honestly try using my log rules instead. So if they had like terms, I would collect them. And if they don't, then I turn to my log rules. So I do see that we have addition and we have subtraction, and we do have the same base because the log rules only work when we have the same base. So I've got addition and I have multiplication. Order of operations, or BEDMAS, says that we start with brackets and exponents, then we move on to division and multiplication, and then we do addition and subtraction. So I have addition, subtraction, and some multiplication here. So the thing that I need to start with first is my multiplication. Now, can I multiply log of 5x by 2? Not easily, because I can't work out what log of 5x is. So I would see if there's a rule that would help me with this. So we have the third rule down that says, if we do it backwards, when you have something being multiplied by a log, you can bring it up as an exponent. So I can take that 2, not a negative 2, just the 2, and we're going to bring that up as an exponent on the 5x. So we're going to have log of 5x squared plus log of 20x to the 14, and then minus log of 5x, and then I need to square that. It's not just the x that gets squared, it is the 5 and the x together that get squared. So I would say that the whole argument is squared, meaning we are going to square the 5 and square the x. This is just a monomial, it's one term. I don't have to use FOIL or anything to multiply it out. This is just 5x times 5x, or 25x squared if I square the 5 and the x. So I have log of 5x squared plus log of 20x to the 14 minus log of 25x squared. Okay, so now that I took care of the multiplication, it's not an issue anymore, it's gone. I wrote it in a different way. I'm going to use my rule that comes first, which is addition. So I'm going to combine those two logs by multiplying their arguments together. So this is going to be log of, I'm going to multiply 5x squared and 20x to the 14. 5 times 20 is 100. X squared times x to the 14. They have the same base, so I would add their exponents. That rule is on the back side of your green sheet, just above where the log rules are. 2 plus 14 is 16. And then I am still subtracting log of 25x squared. Last thing I need to do is find a way to subtract them. I have this rule that says when I subtract two logs with the same base, I would divide their exponents. These do have the same base, so this is going to be log of 100 divided by 25 is 4. And then x to the 16 divided by x to the 2. If I use my exponent laws, I would subtract. So 16 take away 2 is 14. That rule is also on your green sheet on the back page right above where the logs are. So I'm down now to one log. So I have log of 4x to the 14. Now, are there other things I could do to write that in a different way? Sure, but when we're trying to find a simplified expression, our goal is to try to get it down to as few terms as possible. I feel like one term is pretty much as few terms as we're going to get it down to. So I would stop there at log of 4x to the power of 14. All right, I will see you in the next video to take a look at our next question.